Another question is here. The velocity in meters per second of a particle moving in a straight line after t seconds is given by v equal to 4 plus 8t minus 2 square. Calculate the acceleration of the particle after 3 seconds. Now we have speed, velocity, that is velocity here, we call it velocity. We want acceleration. How do you get acceleration? So from velocity to acceleration you differentiate. So now we have v equal to 4 plus 8t minus t square. So to get acceleration you differentiate. So acceleration equal to dv equal to dv over dt, which is, now we differentiate, this one is 0, this one will be 8, this one will be minus 2t, and that is velocity. So because we I hope you know how to differentiate a function. So I'm thinking that you know how to differentiate as a function. So but we are told to find acceleration of the particle after 3 seconds. So where we have t, we are going to substitute with 3 because 3 is the time. So that means acceleration equal to 8 minus 2 into 3, which is equal to 8 minus 6, which is the same as 2 meters per second square, and that is acceleration. B, the distance covered by the particle between time equal to 2 seconds and time equals 6. So these are the limits. So we want the distance. How do you get the distance? Distance is equal to s. So we integrate velocity for us to get, you should know those things, that if I want the distance and I have velocity, what I will do, I will integrate. If I have velocity, I want acceleration, I will differentiate. So those are the things you need to understand. So distance is we use s to stand for distance equal to integration of velocity, and our velocity is 4 plus 8t minus t square. We put a bracket and then dt. So let us integrate this. We remove the integration function, but we have the limit. Remember the limit, our limit is time equal to 2 and up to 6. So you should remember that. So we are integrating this function under the limit 2 to 6. So let us integrate this one. So we will have 4t plus 8 t square divided by 2 minus t cube divided by 3. Our limit, the upper limit is 6, the lower limit is 2. So we are integrating this one there. So this one is the same as 4t plus this one's here, that is 4t square minus t cube divided by 3. I've simplified 6, 2. So let us now, this one is time. Therefore, where we have t, we are going to substitute by 6 and then later by 2. So we are going to have 4 into 6 plus 4 into 6 square minus 6 cube divided by 3, everything minus, when the limit is 2, that is 4 into 2 plus 4 into 2 square minus 2 to power 3 divided by 3, and everything here will give us 96 minus 21.25. This one will give us 74.1 over 3 meters, and that is the distance. Determine or calculate the time when the particle is momentarily at rest. The time when the particle is momentarily at rest. Always remember that when a particle is momentarily at rest, velocity equal to 0. Very important. So our V equal to 4 plus 8t minus t square. But now this velocity 4 plus 8t minus t square is equal to 0. So we want to get time when velocity is 0. So we will have t equal to negative 0.472 or t equal to 8.472. That is the time when you find this value. You will find the value of t to be this or this. Now we have time to be negative and another time which is positive. Time cannot be negative, therefore you ignore the value with negative. That tells you that the required time equal to 8.472 seconds. So the time when the particle is momentarily at rest is 8.472 seconds. Ignore the negative because time cannot be negative. Calculate the distance covered at the end of 3 seconds. At the end of 3 seconds. This means you find the distance when time equal to 0 and time equal to 3, because covered at the end. So we know distance s equal to integration of velocity dt. We integrate velocity. Now this one equal to, our velocity is 4 plus 8 t minus t square dt, but our limit is from 0 to 3. So let us integrate. This one is going to give us 4t plus 4t square minus 3 minus t 3 over 3, but our limit is 3 to 0. So when we use that one, we get, so substitute t with 3, so that is 4 into 3 plus 4 into 3 square minus 3 cube divided by 3. This one will give us 39 minus 0, and the answer is 39 meters. So the distance covered at the end of 3 seconds. You remember we are asking at the end, so it must have started at somewhere at the 0 so that it can end at 3. So that is the only trick in this sum. Part E of the question is that calculate the distance covered during the 4th second and of its motion. Calculate the distance covered during the 4th second of its motion. The 4th second. No, now during. Will you start from 0 to 4? No. During the 4th second, it means between the 3rd and the 4th second. That is the only trick you need to know. The distance covered during the 4th second means the time between the 3rd second and the 4th second. So you integrate velocity using the limits of 3 and 4 seconds. That's as simple as that. So find the distance. Now we know that distance is equal to integration of v dt. So we know that the integration, that is 4 plus 8t minus t square dt. This one is going to be 4t plus 4t square minus t cube over 3, and our limit is going to be 4, 3. So So this one is going to give us, so when you substitute everything here, you get 58, 2 over 3 minus 39, and that one is going to give you 19.2 over 3, or 19 2 over 3, or 19.67 meters.